Alright, we're talking about trigonometric ratios. I kind of forgot to start the video, so we're getting into it. We got sine, cosine, tangent, and as you can see, our opposite, hypotenuse, opposite, adjacent, all those things we did in the warm-up are big time coming in right here, okay? They have 3-letter abbreviations. So if you see, we've got sine, and it's just represented as S-I-N. You don't really say sin, right? It's kind of one of those like cringe things when kids are like, oh, sin A, sin B. Just say sine, all right? You got sine A, sine B, cosine A, cosine B, tangent A, tangent B. Sin, cos, tan, but don't say it like that, right? That's kind of amateur hour. And as you can tell, you might have to do the sine of A, you might have to do the sine of B. If you look at your triangle over here, A is the triangle at the top, and B is the triangle at the bottom. Now, that means that sine A is going to be different than sine B, because you're going to have different perspectives, just like the warm-up we just did. I hope you're seeing kind of the connections to what we just did. If you're at sine A, you're going to have a different ratio than if you're at sine B. So let's see it. Sine is the ratio of the leg opposite the angle to the hypotenuse. So we're going to make a fraction that has the opposite on top of the hypotenuse. Which, again, we've done a lot of vocab here. All we got to do is put 2 numbers on top of each other. That's it. Like, as crazy as this all sounds, actually doing it isn't super tough. Here's the A. From the sine of A, focus on this angle up top here, A. What small lowercase letter is the opposite? Is it lowercase b, lowercase a, lowercase c? The opposite is all the way across from the A, which would be the little a. So sine A would be the opposite divided by the hypotenuse. And which of these little letters is the hypotenuse? Little c. That's the sine of A. Just follow with me. The main thing that you're trying to like associate right now is this. That sine is the opposite divided by the hypotenuse. When we go to sine of B, we're going to change our vision. We're going to look at this B angle now. We are positioned here at B now. We're not positioned at the top, we're positioned at the side. And it's going to be the opposite over the hypotenuse. We know that the hypotenuse is not going to change. We still have C as our hypotenuse, because the hypotenuse is always the longest side, which never changes. But the opposite angle has shifted now. From the top, the opposite is at the bottom. But from over here on this right side, angle B, the opposite is side B, little b here. All right, before we move on, it's a strange thing where you have very crazy sounding words, but don't overcomplicate the process. We're just trying to put the O on top of the H. You just did a warm-up where you identified O's and H's, and you got 100. So all you got to do is take the O, take the H, make a fraction. What do you got? If you make it fast, I can accept it. Okay, let's see what comes next. Cosine is the ratio of the leg adjacent to the angle and the hypotenuse. So cosine is A divided by H. Now, that is not rocket science. Instead of using the O, you just use the A. Not that tough. If you can identify the O's and the A's, you can handle this. Both of them are going to be fractions. And both of them have the H on the bottom, which is also very easy. Which letter is the H? It's always going to be C because the hypotenuse never changes. But when it comes to the tops, we got to slow down a little bit because the adjacents do change. The adjacents are important. The first piece is talking about the cosine of angle A, which means I'm standing right here. I'm standing at the top. Look at this angle for like 5 seconds. I'm here, I'm here, I'm here. Gotcha. Now that you're here, now that you're focused on this angle, which one is adjacent, A, B, or C? It would be the letter B. The letter B is adjacent to letter A. The side B is adjacent to the angle A. Now change your perspective. Now we're down here. What side is adjacent to letter B? Letter A. And you're probably putting the patterns together that, okay, sine A was AC, sine B was BC. Then when you see cosine A, it's kind of flip-flopped. It's not AC anymore, it's BC now. Because our O's and our A's have rotated when we're doing it. Okay. The last one is tangent. And tangent is the opposite with the adjacent, which means tangent is O over A. Now this one doesn't use the hypotenuse at all. So we can't just make a fraction and lock in the C instantly because C is not going to be used at all. We got to put the O over the A. When it comes to tangent of letter A, focus on this letter here for 5 seconds. This is where you're going to be standing. This is where you're hanging out. Which letter is the O? Which letter is opposite? All the way opposite letter A is side A. So we're going to have side A right there, which is a little confusing because we use the A to represent the opposite. I get that, but you'll have to handle it.
I'll be getting messed up because sometimes it'd be like you will be standing at an angle and not on one of the sides.
So you're always standing at an angle, if that makes sense. So where it says tangent A, you're standing at this angle A. When it says tangent B, you're going to be standing at that angle B. You're always standing at the angles. All right, so if we got the opposite is A, what's the adjacent? It's B. So we should have A over B. And when we switch it up, when we go to angle B, what's the opposite? And what's the adjacent? So we should have B over A. All right, this can be a little bit of like a brain twister, tongue twister. All right, but just slow down, make sure you know where you're starting, and basically you have these 3 fractions, and your job is to learn that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, how do you remember that? Because that just seems like a bunch of random letters to me. There is a classic, iconic mathematical mnemonic to help you remember this, and it is SOH. TOA. And it sounds...
That's why I said that on the computer.
Exactly. That sounds kind of like Native American, I always think. SOH, right? It reminds me of like Pocahontas. I don't know. Maybe these days that might be pushing it, but that's how I always think about it. SOH. And it sounds like nonsense, but it's really easy to remember. And honestly, if you go to some teacher in the school and you just say, hey, I know you're my English teacher, but do you know how to remember sine, cosine, tangent? They might even be able to tell you SOH, because it's just really easy to remember. All right? And why the heck do we remember it like this? Well, the S stands for sine, and the O stands for the opposite, and the H stands for the hypotenuse. So sine is opposite over hypotenuse. And that's where your SOH comes from. SOH. So, and then your CAH. What do you think the CAH is? Cosine, adjacent, hypotenuse. And then the last one is TOA, which is tangent, opposite, adjacent. And literally every single geometry student in the entire nation will learn SOH. This is not like Mr. Collier was scrambling to come up with this. Literally every student who's learned geometry in the last 50 years has probably memorized SOH. Okay, so when it says, and we're going to do basically these 3 questions before lunch, and we're going to do a little classwork after lunch with these, with these angles. We're trying to do the sine A, cosine A, tangent A, sine C, cosine C, tangent C. And all of these are going to make fractions. And I'm going to kind of stagger them so that they don't look quite as confusing. All of them are going to make fractions because they're all ratios. And just before we move on, for this question, we're doing sine A and sine C, but we never asked the question about sine B. So what's up with sine B? B is the right angle. You're never going to be standing at the right angle. If you think about what we did for this question, it was angle A, angle B, angle C, and we did never talk about sine of C because C is the right angle. We're never going to be positioned at that right angle. All right, so let's get into this. Some people may literally already be done with number 1 because all we got to do, there's zero math here. We just have to place the number where it's supposed to go. You don't have to add numbers together. You don't have to subtract numbers together. You just have to identify them, okay? If we remember, and I would definitely copy as much of this down for you now that you're back. If we can remember that sine is SOH, it's the SO part, which is opposite over hypotenuse. What we need to do is grab the opposite number and put it on top. For the A position, which is over here in the A position, what's the opposite number? 5. Nice job. 5 is the opposite. If you were standing at A, 5 would be all the way across. So, SOH, hypotenuse goes on the bottom. Which number is the hypotenuse number? 13. So we put 13 on the bottom. All right, then we just move on. We don't have to do anything. We just next, okay? Up next is going to be cosine. Cosine is the CAH middle portion, which is AH, adjacent hypotenuse. The hypotenuse we know 13. That's not changing. But the adjacent, instead of 5, we labeled the opposite. 12 is going to be the adjacent. Then we have tangent, which is the TOA portion, which is opposite over adjacent. So now we're going to not use the hypotenuse. What's the opposite number? 5, and the adjacent number? 12. And so our tangent is going to be 5 over 12. All right, we just did SOH. We just did sine, cosine, tangent of a triangle, considering that we're standing at letter A. We feel okay about this? If you feel like it's just magical, words that are coming out of nowhere, then you might be trying too hard almost. You're just kind of consider you're at one of these angles and take them. So we're going to do the same exact thing, except for we're going to reposition ourselves. Instead of positioning ourselves at A, we're going to reposition ourselves at C. Stare at C for like 5 seconds. And just really imagine that you're standing there at that C. And then I got it. All right? I'm here. The sine of C, so opposite over hypotenuse. What's up? If you make a pass. The opposite over hypotenuse from here is going to be 12 over 13. Now what about the cosine of C? It would be the adjacent. I'm standing in this corner now. I'm adjacent to 5. 5 over 13. And then we're going to finish with the tangent, and the tangent is opposite over adjacent, 12 over 5. So, before we get to 2, and I'm sure you have a question, number 1, any kind of stress about number 1, or are we finding it relatively simple, right? Just grab the opposite, grab the adjacent, grab the hypotenuse. Now, all you have to do is identify which one's the opposite, and so if you do that wrong, you're going to get the question wrong, right? If you're standing at C, the 12 is the opposite. And if you accidentally say that 5's the opposite, you're going to be wrong, right? It's not a lot to do, which means if you do that part wrong, you're going to get the whole thing wrong. Now, let's see number 2. Same idea. We got, x, w, y, whatever, w, x, y, however you want to think about it. We're never going to think about the sine of y. We're always going to be thinking about it from the 2 sides here. But this one, we got kind of an issue because we have a missing side. We have that missing piece. What do you say? So how are we going to find this side? So the sine and the cosine, they don't really help us find numbers like, oh wow, now that we did the sine, we know what the mystery side is worth, right? So before we even get to the sine and cosine, what is something we've learned? How do you find the third side of a right triangle? All we did all week, right? Pythagorean theorem. A squared plus b squared equals c squared. We know that a right triangle is always going to satisfy this Pythagorean theorem. We put the sides in, and remember, we got to make sure they go in the correct place. The 9, is the 9 a leg or is it a hypotenuse? It's just a leg, so it can go in the A spot. Good enough. What about the 12? Is the 12 a leg or a hypotenuse? It's a leg, so it can go here. And just like we thought, we're trying to find the hypotenuse. Maybe we can put an X here. Doesn't make a whole lot of difference, but we do this. We go to Desmos. We type this in. We'll get the answer. Going to Desmos. We got 9 squared plus 12 squared equals x squared. Zoom out. Use the positive number, and I got 15. Excellent. Let's go with 15. Okay? A little bit of Pythagorean theorem to begin the question. That doesn't add a ton of difficulty, right? It's just a quick formula. We've been doing it all week. We've been, hopefully getting pretty good at it. And so now we have the sine of w, and we should be able to handle this because we have all 3 sides. Let's pick up the pace a little bit. The sine of w, we know that sine is it's the opposite over hypotenuse. And so what is the opposite number from w? Is it 9, 12, or 15? It is 12. 12 is opposite. What's the hypotenuse? We just found that. It's 15. And question number 2, unfortunately, does bring one more step in. We've already had to do 2 steps. 12 over 15 is not simple enough. If you notice the directions here, it says, you know, give each trigonometric ratio as a fraction in simplest form. So we're going to need to take this 12 over 15, and we're just going to need to go into Desmos. 12 over 15, it's going to be a fraction. 4 over 5. So the best answer here is going to be fraction 4 over 5. That is our simplest trigonometric ratio. Now, we've been going kind of slow for this question. We started off with hypotenuse, we did it, we simplified it. Let's pick up the pace a little bit. Cosine, CA, the middle one, adjacent hypotenuse, fraction. We're at the W, the adjacent is 9. And we know the hypotenuse never changes, it's a 15. Double check that this is good enough. Desmos, 9 over 15, and I got 3/5. All right? 3/5. And let's keep it going. The tangent from W. The tangent should be the easiest one because you've already identified the O for your sine, and you've already identified the A for your cosine, so just put them together, right? Tangent. The opposite is 12. And the adjacent is 9. Use Desmos and try out 12 over 9. 12 over 9 is fraction 4/3. So true, so true. All right, here's what we're going to do. Forget that. We don't need to do that. I think we get it. I'm going to give you, some time now to try number 3. See as far as you can get. Start it off, use the Pythagorean theorem. That's how you're going to find your missing side. And then consider that you're standing at side or angle L. Grab it, make your fraction. Grab it, make your fraction. All right, if you don't know how to start this at all, you're falling behind pretty quick on the first day of trig. So let's raise our hand, let's work together, let's make it happen. We're going to go over this at 1:12. So I'll give you 3.5 minutes. You should hopefully at least be able to get all of these L angles figured out. All right, hopefully you're starting off and you're writing a squared plus b squared equals c squared. Oh my gosh, I told you I'd get you one, I forgot. Sorry about that. Somebody said Mr. Collier? Are you talking about for the Pythagorean theorem? Yeah, that's what we're on.
So did you put that in that one?
Hold on. You said it like this, you said it wrong. Oh. Make sure for that Pythagorean theorem you're putting those numbers in the correct place. Look, this is hypotenuse. Make sure you're putting that hypotenuse where it's supposed to be.
First of all, you got 18, you said 16.
You did the whole thing with the 16 squared plus the x squared equals 34 squared. Cool. So now you got set up and you got 34. Looks perfect so far. Yep, do that, and those are your simplified best answers. Okay. So if you're standing at L, and this is where you are, obviously 34 is not possible. Is this opposite of you, or is this? Sometimes it's easier to think about adjacent first, because adjacent is next, x2. So that's 16 is your adjacent, so you got those done. Is it? 8, not 6. Is that a 4 or a 6? Oh, yeah. So that does look pretty good. But then you gotta make sure that you simplify it. Yeah. Okay. Good job. That is gonna be like impossible to do until we do it together. So I wouldn't think about that like that. That's a whole different. What do you say? Yeah. Let me do this, and then that'll be it for the notes, and I'll give it to you right when we're done. All right, so let's see what happens here. Let's go through it. I'm pretty impressed. I mean, honestly, trig is one of those things, like, no fear. You can do this. It's just putting those things where they're supposed to be. So, starting off, we need to figure out what our missing side is. A squared plus B squared equals C squared. And make sure that hypotenuse, the only thing for Pythagorean theorem is that the hypotenuse has to be the C value. The 34 is the hypotenuse. 34. The 16 can go in either one of these. We can use an X, and let's use this on Desmos. 16 squared plus X squared equals 34 squared. Type it in, look for the positive one. I'm getting a perfect 30. That is excellent. 30. Now, I'm doing the sine, cosine, and tangent of L. So, I'm gonna I'm going to be standing here at the L. Here's my little person. And I need to consider the sine, which is the opposite over the hypotenuse. Welcome back. Here we go. So, if I consider the sine opposite over hypotenuse, it's going to be a fraction. Opposite me all the way across the field is going to be the 30. The hypotenuse is 34. And I go to Desmos to try it out. We got 30 over 34, fraction, 15 over 17. Final answer, 15 over 17. If you got that, honestly, you pretty much get it, okay? Let's finish out this question. The cosine is going to use the adjacent number 16 over 34, and just to save time, I hope you got 8 over 17. The last one is going to be the tangent, which is the opposite over the adjacent. And what I tried to show you in the last question is that we already found the opposite right here, and we already found the adjacent right here. So if you just borrow those, you don't even have to look at the triangle again. You can just grab the O from the sine, grab the A from the cosine, and just go straight here. 30 over 16. Type that in. Again, just to save time, I hope that you got 15 over 8. From the M position, I'll just give you the answers. From the M, it should be opposite hypotenuse simplified 8, 17, 15, 17. Have a good lunch. 8 over 15. Classwork when you get back.